Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied that how to derive the relation between the rate constant for the first order reaction with respect to the concentration of the reactant. And now we are going to be dealing with the numerical based on that equation. So let us solve it. As on your screen it is mentioned a numerical which is based on the rate constant for the first order reaction. So let us see and extract the data and fulfill the requirements asked in the question. So first of all, it's been mentioned the rate constant for the first order reaction is 6.8 into 10 raised to minus 4, means the rate constant K is been given. If the initial concentration of the reactant is 0.04 molar, means initial concentration in this case A0 is 0.04, A0 is 0.04 molar. What is the molarity after 20 minutes? Again, the time period is also given, that is T, which is 20 minutes. It has been given, and on that basis, we have to calculate what is the final concentration, that is, what is the molarity of AT. And now, after that, it has been asked that how long it will take 25% of the reactant to react. So, let us solve these two questions which are being given to us. So let us start with the first one and let us write the data first and then we'll do the further part. So the given data is rate constant is given and rate constant is denoted by K, that is 6.8 into 10 raised to minus 4 per second. The initial concentration, that is A0, is been given as 0.04 molar, and that of the time period is also given, which is 20 minutes. But it should be mentioned very clearly, when the rate constant is given in per second, we have to convert the given time of the question in seconds only. If it is given in minutes, means I am talking about if the rate constant is given in per minute, then we have to convert the time into minute. If it is in second, we have to convert it into minute. If it is in hour, then also we have to convert it into minute. We should note that the value of the unit of constant and the unit of time required to do the reaction should be relevant to each other, should be related to each other. So we are now converting this 20 minutes into seconds. So therefore 20 into 60, it is 1200 seconds. And the data that has been asked to find is the molarity after 20 minutes, means the final concentration. There's another question also, but we'll solve it later, right now itself. But first of all, we are going to solve this question. So for this, we know the formula, that is for the first order reaction, K is equals to 2.303 divided by T log of A0 divided by AT. Now the value of K, we will substitute here. The value of K was found to be 6.8 into 10 raised to minus 4, while that of the time was being estimated as 1200 seconds, and that of the value of A0 was being given, but we'll not write it first because now we have to first of all solve this thing and then only we could find that what will be the log of A0 divided by AT. So it will be very much easier to solve. So that's why I am not mentioning the value of A0 here right now. just for an instance. So let us see what is the value of log of A0 divided by 80. So log of A0 divided by 80 will be nothing but 6.8 into 10 raised to minus 4 multiplied by 1200 divided by 2.303. So let us see what is the answer. The answer is 3543.2 into 10 raised to minus 4. So I could write it as 0.3543. Fine. So this is the value of log of A0, that is A0 divided by 80. But this is not the final answer that we have to calculate. We have to calculate the value of 80. So how can we do that? So since we have got the value of log of A0 divided by 80 as 0.3543, what we are going to do is we will take the anti-log of this thing so as to get the value of A0 divided by 80, and then only we could do the further part. So therefore A0 divided by 80 will be the anti-log of 0.3543, which is 2.260. So the value of A0 divided by 80 we have got as 2.260, and now we are free to substitute the value of A0. So the value of A0 is nothing but 0.04 divided by 80 is equals to 2.260. Therefore the value of 80 will be, or the concentration of reactant after time t will be 0.04 divided by 2.260. And let us see what is the answer. It is 0.0176 molar. So the value of 80 is 0.0176 molar after 20 minutes. So this is the answer that we have got for reactant after 20 minutes. But this is not the final answer. Another question is also left, in which they have said that how long it will take for 25% of the reactant to react. It means what? It's a very easy numerical. So let us do with a very deep sense. They have asked 25% of the reactant has been reacted. If 25% of the reactant has been reacted, means obviously the initial concentration would be 100%. So on that basis, I am denoting the A0 as 100%. I would not write it as in percentage, because I know, because it is 100%, I could take it as 100 gram, or I could take it as 100 moles per dm cube, because it is a percentage. I could take it in this way also. And ultimately they have said 25% of the reactant has been reacted, which means after a few times 25% out of 100 has been reacted. So the amount that is left with me will be 100 minus 25. So 100 minus 25, it is nothing but 75. So this much amount we have left, means we have the reactant which is left. And again, the rate constant which is given to us is again 6.8 into 10 raised to minus 4 per second. So based on this thing, we could calculate that how long it will take, means how much time it would have been took to convert 100% of that reactant to 75% of the reactant. So we have the formula. Again, the formula would be the same, but in this case the values has been changed. The first numerical has been solved. Now we are solving the second data. So in this case, again the formula would be the same, that is k is equals to 2.303 divided by t log of a0 divided by 80. So we'll substitute the value and we would find what is the value of t. So therefore 6.8 into 10 raised to minus 4 into is equals to 2.303 divided by time, and this time we have to calculate log of a0. In this case a0 is nothing but 100 divided by 75. So let us see and let us calculate first the log of 100 divided by 75. So which is nothing but 0.1249, and the value of k is 6.8 into 10 raised to minus 4. So what we are going to do is we are going to find out the value of time. So now the value of time t will be,
सर एक मिनट रुको ये देखिए थोड़ा गैप दो सर एक मिनट
sorry no I guess, therefore the time will be 2.303 into 0.1249 divided by 6.8 into 10 raised to minus 4, which will be 0.042 into 10 raised to 4, which means 420. And what would be the unit of this? The unit of this will be, see, the unit of rate constant was given in seconds per second, so the time would be also be in second. So it is 420 second. So which means 420 second will be required to convert the 100% of the reactant to 75% of the reactant, and this was because of the help of the rate constant that was being provided to us. So thank you friends for liking this video. I hope you will do such kind of numericals in your future by extracting the data from the numerical and also finding out through the help of formula. Thank you so much, and please don't forget to subscribe Ekeeda channel. Thank you so much.